We're not doing anything sophisticated. If you're familiar with law of sines, law of cosines, we're not going to get that far. Just right triangle trig is sufficient. Anybody not, is this completely, to whom is this completely foreign? Okay. So these are the three main trig functions right here, that the sine of an angle, generally abbreviated as sin, pronounced sine, is equal to the opposite over the hypotenuse. So if I have some angle right here, the sine of theta in this particular case is the opposite side divided by the length of the hypotenuse, which is square root of 74. Or let's go ahead and do the 8.66. So on a calculator, theta would be the opposite of, you want to get theta by itself, so you need to do the opposite of sine, which is the arc sine of 7 over 8.66, which on some calculators, or say specifically on my calculator, would be a sine of 7 over 8.66. And if you have the TI-80 whatevers, it'd be sine -1 of 7 over 8.66. Missing the board when it was half foot higher. For one brief day, the board was up here. All right, cosine. Oh, yes.
Why, when you moved the sine over, why did you have the arc? Change it to arc sine?
The inverse sine. If I want to get rid of sine here, I have to do the inverse function, which is arc sine. Are you?
Is that the same as like cosecant?
No. No, the cosecant is the reciprocal function, not the inverse function. So if sine of theta is x, then theta is the arc sine of x. So what angle do we get it? Did you do this?
54.5 degrees.
54.5 degrees? All right. Cosine. So the cosine of an angle is equal to the adjacent side. Now I have had students in the past who get confused by what's adjacent because they're picturing, well, this is adjacent to that. Picture yourself in a room with 3 walls. You're standing in this corner. This is not adjacent, it's the one opposite you. The adjacent side is this. So the cosine of theta is 5 meters over the hypotenuse. That's the h, adjacent over hypotenuse, which is 8.66. So my angle this way would be the arc cosine, or inverse cosine, 5 over, meters cancel out, 5 over 8.66. I'm hoping you get the same thing. Could be off by rounding. Someone else also working on it? Yes.
I just have a question. I never took trig, and this is very foreign to me. So whenever you take it from the cos, what's that sign next to it? That
What,
looks-
this?
Yeah, cos
Oh,
what?
it's COS, short for cosine.
And what's the sign beside it?
This right here, that's the symbol for my angle. That's Greek letter theta.
Theta.
Yeah, I have to label, this is my unknown, so I just gave it a label. And typically angles are use Greek letters.
Okay, so whenever you put this in the calculator, you said that the units go out because you flip the sign?
No, the units go out because the opposite side, this length and this length and this length, they all have the same units. So when I divide, the units cancel out.
Okay, but say one was like 5 meters and one was 7 like centimeters, they would stay.
Then you would have to change them into the same unit in order to use your calculator.
Okay, thank you.
Yeah. if calculators assume that the units have canceled out. At least all the ones I've ever dealt with. What do we have?
All the inverses of those functions, the same as like, it'll be sine -1 in the calculator.
Yeah,
Same
well,
function.
depends on what calculator you're using, but on your calculator, this would be cosine -1, 5/8.66.
You said depending, like a TI-83, would it be
Yeah,
like that?
the TI-80 whatevers do the -1. Like HP does A sine and A cosine. My math textbook, when I was learning this stuff, spelled out the word arc for arc sine and arc cosine. So what'd you get?
54.7.
54.7?
Degrees.
Thank you. And then, the way that Coy had actually suggested, tangent, that's the T right here, tangent. Tangent of theta is the opposite length divided by the adjacent length. So that would be 7/5, or 1.4. So theta is the arctan of 1.4. And what do we get this time?
54.5.
54.5?
Degrees.
All right, so we actually have, these two agree and that one is different. Which is the most correct answer?
The 54.5.
Why is that the most correct answer?
Well, didn't you say if one has more than the other, you're gonna go with the one that is the most?
Ah, okay. Is there a mathematical reason as opposed to majority rules?
Because 5 and 7 are numbers that we started with, not numbers that we found.
Lionel, please.
5 and 7 are numbers that we started with, not like a number that we rounded off.
Exactly. So traditionally, you would do the ones that requires less rounding off. So since the sine and cosine used that rounded off number, it adds a little bit of uncertainty to those answers. Those just happen to match. All right, questions? Now that you're all experts on this, because I assume you've absorbed it all and that's all you're, okay? Then let's do another similar type problem. So we now have a magnitude, we have a direction, which settling for this one right here. So how would I write my resultant? I mean, with scalars, it's nice and easy because I just, you just add them up, count on your fingers, whatever you're doing, use an abacus. But here, I need to somehow express it. So I know that vectors have a magnitude and direction, so I could write it as 8.66 meters, comma, and then 54.5 degrees. So that's one way of expressing this sum. This is known as polar form. However, of course, there's a simpler way of doing it. Yes?
Are you saying both numbers are known as polar form?
Polar form is this combination where I give you a magnitude and a direction. There's also rectangular form. Now, all I did was just add two vectors. I added one vector because I got a magnitude and direction here. I have a magnitude and direction here. And I added them. So I could also write it as 5 meters east plus 7 meters north. This would, so I got magnitude, direction. This is rectangular form. We're gonna come up with a shorter rectangular form, but this is rectangular form.
So you wouldn't have to do all that work you just did, just
Yep.
put it in that form?
If the question is, what is the resultant just being the vector word for sum, yeah, you could just get away with that.
Is our final exam
Um,
like that?
Which one you want depends upon what's gonna be easier mathematically. There are times in which the other way is actually easier mathematically. That it's worth going through that pain because it's gonna make the next step easier. All right, so, but this is too much writing. It is. So let's come up with something shorter. So let's just say that this way is east, and I'm just gonna do an E with a little hat on top of it. And this way is north, and I'm just gonna put a little hat on that. And so I can now write this as 5 meters east plus 7 meters north. It's a little bit simpler. If you ever see a vector with a hat on top of it, this is known as a unit vector. This indicates unit vector. Unit vectors, they're vectors. They have a magnitude and a direction. What is the magnitude of a unit vector?
1.
Yeah. The magnitude is 1. So I'm going to represent that as, I can put absolute value symbols around it. The magnitude of a unit vector is 1. There are no units itself. Some textbooks will put the double lines on both sides to differentiate it. I tend to do just the 1. The direction of a unit vector, for most of the unit vectors, we'll deal with this in this class. The direction is whatever I say it is. Or if you're working the problem, whatever you say it is. That's why I had to define it here, because I'm now establishing what those mean. However, east and north, not necessarily convenient. So instead, I use something more generic. Instead, I'm gonna write I hat, J hat. My final answer is 5 meters I hat plus 7 meters J hat, and that's my answer in rectangular form. So we have multiple ways of expressing the same thing. And the reason why I prefer I hat, J hat, who sat physics before? Did you use X hat, Y hat, I hat, J hat? I and J. Okay. Some books and some instructors will use X hat, J hat, or sorry, X hat, Y hat. And the issue I have with that is that goes, people are so brainwashed into X, Y. And sometimes it's really more convenient to have that direction and that direction as what you're defining. Depends on the problem. There's, at some point in chapter 4 or 5, I worked through a problem the efficient way where I have I hat, J hat at a tilt. And then I work it through it where I go with this, and it basically quadruples the amount of math you have to do. Yes?
Just a question, because I guess I'm still stuck in like math 171, so that has nothing to do with absolute value? The law?
It does, if you think about, here's the connection. Let's get rid of this. All right, so if I think about a number line, that's 0, 1, 2, -1, -2. The absolute value of 2 is 2, absolute value of negative 2 is also 2. So if you think about absolute value as the distance from, the shortest distance from 0 to wherever, whatever you're taking the absolute value of. In 2 dimensions, I had 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. That, my resultant was there. The absolute value of the resultant, if you think about that, it is the distance from here to 0, which in this case would be 8.66. So that's how they're connected.
Okay.
Other questions? Or follow-up questions? Or even the same question?
So the absolute value of the result would be 8.66, but what about why are the magnitudes specifically 1 for the 2 directions?
The magnitude is specifically 1?
You mean, like, for E, why is that 1?
Because unit vectors have 1. Because the point of a unit vector is to shorthand notation for indicating direction. You don't want the unit vector to change the magnitude. So, in essence, over here, it's 5 meters times, it's an understood multiplication, times this. Because that has a magnitude of 1, 1 times 5 is 5, it's very clear that this is 5 meters. If I added some other magnitude of my unit vector, well, 1, you wouldn't call it a unit vector, but it would make it unclear about how far you actually go in a particular direction. Other questions? All right, so I'm traveling from home and walk 300 meters, angle of 37 degrees, parenthetically go right north of east, and then walk 400 meters, angle of 217 degrees, where am I with respect to home? All right, so you have to define I hat, J hat, and this is one concession I will make to the brainwashing of math. From your point of view, I will assume 0, unless otherwise stated, 0 degrees is this way, 90, 180, 270, 360, or 0 again. So 0 degrees, I will accept without further redefining that 0 degrees is that way. So I put north of east in parentheses there. I don't need it because 37 degrees north of east would be 37 degrees. This is the, call it the physics problem. The math problem, I will write up here. So the math problem is, I want to know where I am from home. numbers there. I'm gonna change that to 217. 127. I wanted something more complicated than he walked this way and then he walked back. The way I originally wrote it, he's 100 meters at an angle of 217 degrees. So this changes to 127 degrees. All right. Now I recommend that you sketch out an answer. It's not required, but sketch out so at least you have some idea. 37 degrees, I know that that's 0 degrees and that's 90 degrees. 37 is a little bit more than a third of the way. Now, I don't know what 300 meters is, but actually I established this. That's 300 meters. My 400 meter vector needs to be a third longer than this one. Now, if I'm adding this graphically, I'm pulling out a ruler and a protractor, I'll have a set scale. But I'm just coming up with a quick and dirty sketch here. So 127 degrees is more like that. I'll just call this A and B. There's A and B. So my final answer is going to be some vector, sort of like that. It's a crude sketch, because of the numbers I picked here. Yes, this can be done in a simpler way than what we're about to do. I believe, unless I made a careless error, it'll be 500 meters, 90 degrees. Let's find out.